Hi guys, welcome back to R programming for SAS programmers. So in today's lesson, we will learn about data frames and we will also go over different data structures that are present in R language. So we already know about the vectors, right? The vectors is like a one-dimensional data structure. And all elements of the vector have to be of same data type. Sometimes it is also called as a homogeneous vector because it has only homogeneous data structure because it has only one type of data in it. Another example of a homogeneous data structure is matrix. Matrix is, you can think of them as bunch of vectors stacked one on top of the other. And again, it's homogeneous. So that means all the elements in the matrix have to have the same data type. The other data structure is array. Array, you can think of bunch of matrix stacked one behind the other. So that's then array. Array is like a three-dimensional structure. Matrix is a two-dimensional structure. Again, they are homogeneous. So these are the three examples of homogeneous data structure. Then we have heterogeneous data structure, where you can have different data types in one structure. So one of them is a list that we have already seen. A list can include a vector, it can include a matrix, it can include an array, it can include a data frame. A list can include a list within itself. So list does not have many rules, not so much restrictions. You can put anything in the list. Now let's talk about data frames. Data frames are similar to matrix. They are two-dimensional in structure, but the difference is that you can put different data types in a data frame. And it is like the most common data structure used in R. And it is very closely, you can relate it to a SAS data set where you have character variable, numeric variables. Similarly, in the data frames, you can have different vectors making a data frame. Each vector again will have the same type, but then you can add two different vectors, one numeric vector, one character vector into a data frame. And you can grow your data frame like that. Okay, enough of theory. Now let's get into programming. We know how to define a vector with the C function or combine function. We learned how to do the factors using the factor function. So we have learned that before in our previous videos. If you haven't looked at them, you can check them out right over here. So now let's see how we can create a matrix. So here in matrix, you use a matrix function, and you remember that matrix is a two-dimensional. So we are giving 4 elements over here, and then we are saying 2 rows and 2 columns. So let's look at it and see how it looks like. So matrix right over here at the bottom, you can see that first row, first column is 1, first row, second column is 3, second row, first column is 2, and second row, second column is 4. So the way how the matrix was populated was filling out the first column first, and then filling it out, and then moving on to the next column. So it's important to know that how the values would get filled in so that you can index it properly and pull the proper value that you want later in the program. Okay, so let's look at the class of this, and it is a matrix, and it says it's an array because if you think about it, matrix is an array with its third dimension as 1. Right? It tells you class as matrix and array. So that's interesting to know. Let's look at type of. It's double because we are having numbers in it, so it's a double type of. Okay, all right. Let's now see how you can derive or create an array. So array, you guys remember, array is a three-dimensional structure. So we have 2, 2, 2. So 2 times 2 is 4. 4 times 2 is 8. So we have 8 elements that we are trying to put into the array. So let's see if array gets populated in the same way as matrix. So we got our first 2 by 2 structure of the array as 1, 2, filling out the column first, 3, 4, and then the next column. And then moving on to the next 2 by 2 structure, and then populating the first column in it, 5, 6, and 7, 8. All right, so let's look at the class of this. In class here it says arrays. It does not say matrix because matrix does not have the third dimension, right? But when we did the class of a matrix, it said, well, it is a matrix or it can be an array. All right, so let's look at type of function on it. And it's a double, same, because that's what the information in it is. And remember, matrix and arrays are homogeneous, so same type of data has to be there. You can't like add a character in it or add a logic true or false in it. Okay. All right, so let's move on. So we are creating an array with only 2 dimensions. Okay, an array with 2 dimensions is basically nothing but a matrix. So let's look at it, how it looks like. We run it. We have our 2 by 2 structure over here. Let's look at class. And there it is. It says matrix and array, right? Even though we defined it with an array function, as it does not have the third dimension, it qualifies to be a matrix. And type of, again, is going to be double. All right, then we're going to check is a matrix, which is a 2 by 2, which we created using a matrix function, and then we created an array with an array function. Again, it's a 2 by 2 structure with the same values put into both. Are they equal? Are they equal? Does R understand them to be equal? And true. It is true. It compares all the values in it, and it says, hey, they both are same. So it can do the comparison as long as the dimensions and things are correct. We can do the comparison. Okay, so now that we have seen the homogeneous data structure, let's go into heterogeneous data structure, data frames, right? I said that data frames are very similar to SAS dataset. So we'll look and try to create one and see why it is true. So you can think of a data frame like a list with all the elements length being equal. Once we create some of them, these data frames, you will understand what I mean by that. So let's try to create a data frame that looks something like this, where we have a study ID, subject ID, sex, age, and arm as the vectors. You can see study is a character vector. We have numeric one. We have mixed type. So we have a study vector that we are going to create with repeat function. You can press F1 to get more help on it, and on the right hand side you will get examples and the whole help for that particular function on how to use it. So we're going to repeat the value AG102 6 times. Okay. The subject ID vector we're going to create using the sequence function. Again, click over there, press F1 key, and then it gets sequence generator. And it will help you over here on how to use it. So I'm going to use a C function with 1:6, and then it will create that vector for me. Then for the gender, I'm going to use the C function and put in the 6 different values for each subject. age, same thing. Arm, again, same thing. So how I am going to create the data frame? I'm going to create the data frame using data.frame function, and then I'm going to pass all the vectors that I just created. So let's take a look at it and see how it looks like. And bottom, you can see we have the data structure, the way how we designed, how we thought it should look like, right? So the advantage of creating a data structure or data frame is that we can add labels, we can add attributes to it. So here we are going to apply attribute called as label. Now it doesn't have to be label, okay? In SAS we have a static label attribute, but in R you can name this attribute anything, and you can put whatever information you feel like in it. So this is not a keyword, the label. But because we are coming from SAS background and we understand label, so that's why we're creating a label. And then we can create label. This is subject ID, study ID. We give all appropriate labels, and then let's see how it affects the data frame. You can see the labels right over here underneath the variable name or the vector name, and here are all the values. That's pretty neat. Let's try to examine the data frame. We can look at the length. Now, unlike in SAS, this length is going to give you the number of, it tells me 5, right? It tells me the number of vectors that are in it that contributed to making of this data frame. So there is 1, 2, 3, 4, and 5. So that's why length of df gives you 5. And same thing, number of columns. Number of columns is also 5, right? But what if you want to know the observation, number of observation? Use the nrow function, and then it gives you 6 right there. So 6 elements we had in each vector. All right, let's move on. Let's use the class function on the data frame and see what we get over here. And we get data.frame, right? It's a data frame. Names, with the names function, like when you have a named vector, it used to give you the names of it. Similarly, over here with the names function, it will give you the vectors that that you have used to create that data frame. So names is that's what it does. And then attribute function, oops, sorry, let's do Control Z. Let's run the attributes function. And in the attributes function, it will give you the names, it will give you the row names, and it will also give you the class. So that's pretty neat. In one single command, you can get a bunch of it. str function. So let's press an F1 on str function. It compactly displays an internal structure of an R object. So it kind of converts it into a string. I think of it like that. It converts an R object into a string and shows it to us. So let's use str. And there it is. We have data frame, and then it shows a study. It's a character. We have integer, character, numeric character, and the values in it, the attributes in it. So it gives like a quick overview of the data frame. I personally like the view option, the view function, to take a look at the values. It's a little bit hard for me to look at the values over here. Okay. Type of is list, right? Think of it. The data frame is a list with all vectors having equal lengths. While in list you can have variable lengths, but data frame is more restrictive and it only allows same length of vectors. Okay, so that's why it is a list. So it does make sense. And view df, that's the data frame. I like this function. It looks very similar to the SAS data set, so that's why I like it. All right, let's move on to subsetting of the data frame. So if we subset it using a column, right? So let's look at this. df1, we are saying df in square brackets, we are just saying number 1. So what happens over here? Let's look at df1 right over here. And only the first study variable or vector got subsetted, right? Okay, makes sense. We are saying 1, so position, we are giving the position of which vector we want. So we want the first vector, and which was the study. Okay, so let's look at print. We'll just print it out, the value right there. Okay, so let's look at the class of df1. It's a data frame. Okay, it's a data frame. So when you use a single square bracket and then you use the position to subset your data frame, it returns you back a data frame. Okay, now if you subset a column by name, right? If you subset a data frame by name, so I'm going to use double quotes rather than the position. I'm going to use the name of the column. So I'm going to call it df2. Let's run all 3 of them together. So here also you can see that df2 is also a data frame. So either you use position or you can use the name. In both the cases, when you subset a data frame like that, the return value is a data frame. Later it will become important why we are stressing on this thing. All right, so we know that data frame is bunch of vectors stacked next to another. So how we can extract a vector out of a data frame? To do that, so suppose we want to extract the age vector out, we'll use the $sign for that, right? We'll use the $sign for that. So unlike the square brackets, and within that we passed the name age, which gives us a data frame, here with df we are going to use the pound sign, a $sign, and age. So let's run this. No errors. We're going to print the value, and here are all the values of that vector. Let's look at the class of it. It says numeric, right? Let's use the type of also over here and see what happens. And it's a double, right? It's a type of double. Let's use nchar, and it will tell you number of characters in each vector, right? So how do we know that that the v1 is a vector? So if you go on the left hand side in our global environment, all the data frames, they show up onto the top place right over here where the data is, and all the vectors value show up on the bottom part over here. So v1 is here and the bottom part, and that tells us that it is a vector and not a data frame. All right, so let's try to extract a vector in a different way. So we used the $sign. Another way of extracting a vector from a data frame is by using double square brackets, and then you can use the name of the vector that you are trying to pull. So let's try to run this guy. And we can print it. So we can see that we have the attribute class is numeric, and we have all the values over here, and on the right hand side you can see v2 is a vector, right? So we learned two different ways of extracting vectors out of a data frame. One is using the $sign, and then other is using the 2 square brackets, and within that you can give the name of the vector that you want to pull. So my choice is the $sign. It's easier syntax to do. So why do we want to pull out a vector from a data frame and not subset a data frame like how we did it earlier, like here? You want to pull vector because you want to use vectorized functions on it. So we can find the mean of the age by just using the mean function, and we can say df $age, and it gives you a mean of 33.16. You can get the range. You can use the range function on it. You can use the summary function on it, right? So it gives you all the minimum, median, mean, first quartile, second quartile, maximum values, right? All of it. You can use a table function. You can use a table function, and it will give you number of males and females, because we use the gender. It's a categorical variable, right? A table needs a categorical variable or a categorical vector as an input. So we gave sex as an input, and it told us there are 3 females and 3 males in it. It gave us the count very quickly. So that's the reason why we want to subset our data frame so that it returns a vector, and we can use the vectorized function on it. So what happens if we try to use if we give a data frame input to a vectorized function? And when we do that, it gives us an error, right? Because it's a vectorized function, it does not expect a data frame as an input to it. So it makes sense. So as we saw, the data frame are list as well with few limitations, right? So when you do a type of for a data frame, it gives you a list. One of the restriction is that you can't use the same name for 2 different variables. So here we have a data frame. We have study ID, subject ID, sex, age, this, and then I'm repeating the study back again over here. So let's see what happens. Does R give us an error message? No error over here. Okay, so then let's take a look at what happened over here. df same name, and R automatically added a .1 or _1 to the name. So name was repeating, it found that, and then it just added 1 to it. So that's how it will restrict it. So you need to be a little bit careful. There is no error message in the log. SAS will give you error message, or it will just overwrite the variable on it. So yeah, you need to be a little bit careful over here with the data frames when making sure that you are not repeating the vectors again. Otherwise, the name of the vector would change. Okay. The another restriction is all elements of the data frame have to be equal. Okay. So let's see if we create an ethnic vector with only 2 values, right? Our vector is with 6 values, and then try to add the ethnic vector into it and try to create a data frame. Let's see what happens with that. Are there any errors? No errors in the log. But then if you look over here, ethnic is populated on all of the 6 rows that we have in the data frame. And what R did again is it took the Asian and white. So let's go back over here. So Asian, white, Asian, white, Asian. It just kept on repeating it, right? And filled out the rest of the values because to follow the rule that all the elements should have the same length. Okay, so you need to be careful. Again, no error message in the log when we try to put in. How about if we try to put in a factor in a data frame? Do we get an error at that point? So here is the factor, and we run this. No error at that point, right? Again, no error, which makes sense because factor is a special type of a vector, right? So you can put that one in, and when you look at the class of it did not change it into a vector. So it just didn't remove the data integrity rule and convert it into a vector. It kept it as a factor. How do I know that? Because on the class function, you can see that it says it as a factor. Now let's try to add an array to a data frame. So here we are creating an array whose dimensions are 3 rows, 1 column, and then 2 stacks of these 3 rows and 1 column. So in total, 3 times 1, 3, and 3 times 2 is 6. So in total, 6 elements. So let's take a look on how this array looks like. So as we said, 3 rows, that's the number 3 over here in the dimension, 1 column, and then the second stack of 3 rows and 1 column. So that's how array gets stored. But then what happens when we put that array in the data frame? So we put that into the data frame, okay, and then we look at the names. So let's look at all the vectors that are in there, and you can see that our sex underscore L is not there at all. But instead we have this x1 and x2, which we didn't even define in our data frame function. They exist over there. So these are the 2 columns, the 2 stacks from this array, and are decided to name them x and then incremented x1, x2 like that. So you have to be careful again over here. No error message, but then R will convert them into vectors. So we can fetch with position number 3, so 1, 2, and 3. So it will give you x1 values over there. There it is. We can use the attributes function on array and see the same thing. We can see the x1 and x2 over here also. Okay, and then yeah, so x1 and x2, if you look over here, are capitalized. They are capital. So if you use a lowercase x over here, it's not going to work. So if I use a lowercase x, it's going to tell me null, right? Because that vector does not exist in that data frame. But if I change it to capital X and then do it, and then it works fine. Okay. All right. So then if we go to df array, now we can also try to pull the value by using the double square bracket function. So we use double square bracket and then give the name of the vector that we want to pull, and there it is, right? What will not work is if I say df underscore with array and then I try to pull this particular vector, because it doesn't even exist, right? So if I try to pull this one, it's going to tell me null over there. Okay, and then class of capital X, I guess it's capital X, yeah, is character. Okay, so be careful when you try to add arrays into data frame. Use a multidimensional one. R is going to change the name of it and then increment 1, 2, 3 based on how many stacks you have. All right, so the next topic is two-dimensional subsetting. So similar to how we use a where clause and a keep statement in SAS, where clause is used to subset observation, while keep statement is used to subset the variables. So we can do similar thing in R. So let's take a look at our, before we do that, let's take a look at our data frame. So our DF data frame, if you guys remember, we had study, subj ID, sex, age, and arm, and these were the values in it. Okay. So now we are subsetting. We are saying first observation for the vector subj ID. Okay, so this is the observation subsetting, and this is the vector or variable subsetting. So let's run this, and we get the return value of 1. So let's go back to the data frame. We said we want the first observation, and we said for the variable subj ID, and then we got the return value 1. So that's it. This is the one that we got in the as the result. Let's try to take first 5 observations, and then we are looking at subj ID and name variables. So let's do that. And it says error in data frame, undefined columns selected. Okay, there was nothing called as name in it, right? If you look at the DF, we don't have a vector called as name. So let's try which one we have. We have subj ID, and we'll say age. All right, let's try to subset it like that, and then there it is, first 5 observation for subj ID and age. If we don't give which columns we want, or we don't give which vectors we want, we don't give which variables we want, it's all same thing, then it's going to show all of them. So first 5 records for all the vectors. We can also use a condition, right? So to subset, we can say df pound age. That's the vector. We are pulling the age vector, and we are saying where age vector is greater than 40, only where this condition is true, I want to see all the values, all the variables where this condition is true. And there it is. We got 2 patients who are above 40, and then all their information is shown right over here. As we go forward, we will see there are better ways of subsetting a data frame. One of the way is using a subset function. Makes syntax much more clear. We have subset df, the name of the data frame. Second parameter is the condition, the where clause. And then the third parameter is which variables or which vectors. And then you can subset it, and you get the results out over here. So that's it. That's all about data frames and data structures in R. In next lesson, we'll bring everything that we have learned so far together. We'll use factors, we'll decode the factors, we'll use our summary functions, and we'll calculate the statistics, and we'll create our data frames and try to create a summary of demographic table using R. So all right, looking forward to meet you guys in the next video.